astronomers are still searching for dark matter, the elusive and mysterious form of matter that makes up the majority of the universe's mass. However, one astronomer suggests that instead of constructing massive, expensive experiments on Earth, we should try a different method of searching for dark matter, looking to the heavens. Multiple lines of evidence point to the existence of dark matter. Despite their incredible speeds, stars are kept contained within galaxies by something. Despite their excessive motion, galaxies are kept contained within clusters by something. Something is bending light's path around massive objects. Something began constructing the universe's large-scale structure long before ordinary matter could. All of that something is currently known as dark matter, and the vast majority of scientists believe it is some new type of particle that isn't currently included in the standard model of particle physics, and evades direct detection because it rarely, if ever, interacts with light or normal matter. In this image, dark matter particles flow through the entire galaxy, including the room you're sitting in right now. However, because these particles are invisible, they have gone undetected. Scientists have spent decades building massive laboratories on Earth in an attempt to capture a fleeting interaction with a dark matter particle, but to no avail. Nature, on the other hand, has its own dark matter laboratories that are far more powerful than ours. Thong Nguyen, an astronomer at Taiwan's Academia Sinica, noted this in a paper published on the preprint database Arxiv. According to the standard dark matter model, dark matter begins to accumulate in the early universe long before regular matter. Galaxies, which account for less than 20% of the universe's mass, are simply pockets of illuminated matter that have fallen into these dark matter gravitational wells. As a result, there should be a lot more dark matter at the core of every galaxy, with up to thousands of times the density of dark matter in the solar neighborhood. So if we want to go looking for dark matter, we'll have a much more difficult time if we stick to Earth-based experiments, because the density of local dark matter is so low. On the other hand, it's not like we can launch an experiment into the galactic center 25,000 light-years away. So, how can we look for dark matter there? According to Nguyen, the answer is neutron stars, which are the cores of massive stars left behind after they go supernova. After black holes, neutron stars are the densest objects in the universe. A typical neutron star packs 2 to 3 suns worth of matter into a volume smaller than Manhattan. They have such high densities that they are essentially mile-wide atomic nuclei. They would simply collapse into black holes if they were any denser. A neutron star's density is critical to its use as a dark matter detector. Although interactions between dark matter and ordinary matter must be rare, or we would have discovered dark matter by now, they do not have to be completely absent. If there is any minor, infrequent interaction between the two types of matter, it is much more likely to occur within a neutron star, simply because there is a lot of stuff to interact with crammed into one. Neutron stars can be found throughout the galaxy, but they are especially common in the core, which is also a hub of stellar activity. There is more material to build stars and more interactions in the galaxy's core, which when combined leads to higher rates of star formation. This results in a large number of dead remnants, such as neutron stars. Indeed, there could be 1,000 neutron stars within a few light-years of the galaxy's center. If dark matter interacts with normal matter, it will have so many interactions that it will lose energy when it encounters a neutron star. A significant amount of dark matter can accumulate inside neutron stars over millions of years. Because of the high density of dark matter, it is vulnerable to annihilation, which occurs when two dark matter particles interact and destroy each other, decaying into other particles in the process. These other particles then produce many other products, such as neutrinos, which can escape the neutron star. On Earth, there are numerous neutrino telescopes, such as the Ice Cube Neutrino Observatory at Antarctica's South Pole. Nguyen searched for an excess neutrino signal coming from the galactic center using publicly available data from these telescopes. Although he did not find conclusive evidence for the existence of dark matter, he was able to limit dark matter's ability to interact with normal matter through this process. While we still don't have a complete understanding of dark matter, concepts like this, particularly when it comes to using nature as a test laboratory, will help narrow the search and, hopefully, reveal the identity of this elusive particle. Subscribe for more updates.